Hello everyone. Today we're going to talk about atomic structure for O levels in IGCSE. So let's start with this first MCQ. It says that an atom of element Q contains 19 electrons, 19 protons and 20 neutrons. Now we do not know what element Q is, and that's exactly what the question is, that what is Q? Now remember that because this is an element, that's the key word here, it's an element, which means the only thing that matters for its identity is the proton number. Because electrons can change, neutrons can change, but the proton is what defines what an element is. So we're just going to look at proton number, and that means we just need to consult the periodic table, and because 19 protons are for potassium, this one is potassium. Next, it says that the table shows the atomic structure of 4 atoms. Which atom is not a metal? Again, we are talking about elements. We are talking about elements identified through proton numbers. So this is again the same concept, that you just need to look at the proton numbers. So out of these, just look at which one is the proton number of something that is not a metal. And that one, as we know, is 18 for argon. So there you go. That is the one that is not a metal. Moving on, which statement about subatomic particles? Now remember, subatomic particles are protons, electrons, and neutrons. These three are the ones that we consider when we say subatomic particles. So let's see, protons and electrons are present in the nucleus. That's actually wrong, because protons and neutrons. Neutrons are negative charged. Neutrons, as the name suggests, are neutral. So this is wrong. Protons are positively charged. That's a universal fact. That is true. Nucleon number is the sum of neutrons. Actually, nucleon number is the sum of whatever is in the nucleus. So that is protons and neutrons. So again, D is wrong. If you look at number 4, it says that an element S has the proton number 18. Again, it's an element that they've identified with proton number 18. Now do not confuse this with sulfur. Sulfur is not the element S we are talking about. S is just a random alphabet that they've taken. They have told us that the proton number is 18. So we'll look at periodic table, and that is argon. The next element in the periodic table is an element T. Which statement is correct? So remember that if you want to identify an element, you just look at the proton number. And the periodic table, proton numbers increase as you go from left to right or top to down, which means that if you're at element number 18, to get to the next element, you have to go for the element number 19, the one with 19 protons. And that we know is potassium. And you can see that potassium is in the next shell. So how is potassium different from the number just before it? It is in another shell because it's in another period. It has 1 electron in the last shell. It's not a noble gas. So all of those things should come back to you. So let's see. Element T has 1 more electron in the outer shell than element S. 1 more electron in the outer shell means you're talking about it being in the next group. It is in the next group, but it's not in group 9 because there's no group 9. It's in group 1. So it has just 1. So it has 1 more electron shell. This means that it's in the next period, and that is true. Element E is in the same group. That is wrong. Element E is in the same period. Again, that is wrong. Question number 5. The symbol of 2 atoms may be written as shown. Now notice how these 2 elements are X and Y, which are again dummy variables, and 23 and 24, the smaller numbers, are the ones that identify the protons. So which statement about these atoms is correct? They're different elements because they have different number of neutrons. That's wrong. They're different elements because they have the different number of protons. Protons is what identifies the element. You see, same concept being tested in multiple ways. So they are different elements because they have their different number of protons. That is correct. They're isotopes of the same element. They are not the same element. If they were, proton number would be the same. So the next 2 options, we just skip them. Which number is different for isotopes of the same element? Again, isotopes are, remember the definition, atoms of the same element, which means same proton number, but different mass, which means different number of neutrons. So neutrons, or the total number of nucleons, is what differs. The total mass is what differs. So anything that implies that. So that is C, because everything else can be same, but C is what is different for isotopes. Question number 7 says the table shows the nucleon number and the number of neutrons in these 4 elements. Which statement about W, X, Y, and Z is correct? So let's see. W and X, the similarity is that they both have same nucleon number, so that their mass is same, but as you can see, their neutrons are different, which means that if the neutrons are different, their protons are also different because they have the same mass. So if I were to just identify the protons, this would be 30 minus 18, which is 12, and this will be 30 minus 20, which is 10. This one would also be 12, and this would be 18. Now, as you can see, these two, they have the same number of protons. I'm showing that as P positive, which shows that W and Y are the same element. And let's see if some option gives us that. W and X are isotopes of the same element. That is wrong because the number of neutrons is different, but the number of protons is also different, so they're not the same element. X and Y are isotopes of the elements in same group. Again, the elements here are number 10 and number 12. Number 10 is neon and number 12 is magnesium, so they are not in the same group. Y and Z are isotopes of the element in the same period. Y over here is magnesium and Z is argon. And the last option is Z has a higher proton number than Y. So let's see, Z has 18 and Y has 12. So naturally, this one is correct. An atom X has 8 more electrons than atom Y. Atom Y is a transition metal. Okay. Student 1 says that they're in the same group. Now, in the transition metals, see if you can have elements that differ by 8 in the same group. So it's in the transition metal, so no other transition metal differs by 8. So I don't think that they can be in the same group. Student 2 says that they are unreactive. Transition metals are not unreactive. Noble gases are unreactive. So that means both of them can't be unreactive. One of them is transition metal. So both of them are actually incorrect. So that is the option C. Which atom has 2 more electrons than an atom of a noble gas? Again, look at any noble gas, move 2 steps forward in the periodic table. So you're looking for something that's in group 2, and that is calcium in these options. So that's the answer. Next question, which of these options for number of protons and neutrons in the atom is incorrect? Now, what are we looking at? We are looking at a positive ion. Positive ion means that the number of protons is more and number of electrons is less. And right now, we can see that it has 5 electrons. So we are looking for something with more protons than this one. So that is only the option B. So there you go. That's our answer. We don't need to look at the neutrons because that's not relevant. All right, so moving on to theory questions. These are options given to us. Now remember, in any of these options, do not write the information from periodic table. Use the information that examiner has given you because they say clearly that choose from the options shown. This idea that you have to choose from the option shown is very important. So do not copy stuff from the periodic table even if it seems same or identical. Part A, which particle can be used that has only 20 protons in its nucleus? We are looking for 20 protons, that's a smaller number, should be 20. So as you can see here, there's only one option, calcium, because that has 20 as the proton number. So we'll just copy that portion, Ca2039. Notice that that's different from the one in periodic table because this is an isotope of calcium. Which particle has a nucleon number of 35? Again, nucleon number is the bigger one. So you can see that this is chlorine. So that's the one with 35. And chlorine 35 is important because there are many other options for chlorine here. So we'll take Cl, put 35 and 17 as it is shown. Which particle has an electronic structure of 288? Again, you're looking for something with 18 electrons. That could be something that has gained some electrons, lost some electrons, or has 18 naturally. So we'll have to look at these. So looking by this, the first 3 can't be because they all have different proton number and they're neutral. Chloride is an option because it has 17 protons, but it has also a negative charge, which means it has gained an electron. Now remember, if you want to figure it out and you're looking for a formula, charge is protons minus electrons. So over here it is -1, proton is 17, so electrons are no doubt 18. So that's the answer. So we'll copy this option, Cl minus 17 and 37, exactly the way they've given again. And I'm stressing that. Which particle is an atom with only 10 neutrons? You're looking for the difference in proton number and the nucleon number. And if you look in the options, this is neon because the difference in these two is 10. 20 minus 10 is neon. So we'll just copy that one, neon with 10 and 20 as they've shown. Which particle has a total of 18 electrons? So that is no different from this one. So you can copy that answer if you want to, because that's exactly how it is, and there's no other one right now that has 18 electrons. Next is saying draw the electronic structure of neon. Now look in the periodic table. Now whenever you're drawing the structure, you have, because they have not shown that you need to use just the valence electron, make sure that you draw all the electrons required. Also, there's no need to draw the nucleus. Just writing neon is good enough. The first shell has 2, second shell has 8, and you have 10 in total. So there you go, neon is done. That's the electronic structure. All right, uranium is a radioactive element and has 2 isotopes. Define the term isotope. Now, there are many ways you can define isotope. The two popular ones are that first we say that atoms of same element with different atomic mass. If you don't want to use the term atomic mass, you can say nucleon number. That's also the same. But another way of defining it in terms of subatomic particles is atoms with same number of protons or same proton number but with different number of neutrons. Now here's the interesting bit. You are basically saying the same thing. Why? Because when you say same proton number, you mean it is the same element. And when you say it has different number of neutrons, you're actually saying it has a different atomic mass or nucleon number. So they're both the same thing. So use any one of these. Now sometimes examiner asks you to define the term isotope, but there is a little extra thing in the question. They say define the term isotope in terms of subatomic particles. In that case, only the second definition would work. First one will not, because you have to talk about the subatomic particles. So just remember to follow the question's requirements. Now the second question is explain. Now every time you have something saying explain, you have to give a reason. That's very important. You have to give a reason to get the marks. So explain why the two isotopes of uranium have the same chemical properties. Now the question is not why they're different. Remember, the question is not why they're different. So do not talk about protons or neutrons here. They're saying why they have the same chemical properties. So let's look at what chemical properties actually depend on. So chemical properties depend or come from valence electrons. And right now, both isotopes have same number of valence electrons. Of course, you can write it in your own term, and you can say that both the isotopes have the same number of valence electrons where the chemical properties come from. That will also be right. So you can write in your own terms. But you have to talk about valence electron, and you do not have to talk about the difference in isotopes. So what's the reason here? The reason is what I've given in the first statement, that chemical properties depend on valence electrons. And that's the reason that they have the same chemical properties. All right, next question. The table shows information about the two isotopes in a particular sample. Use it to find relative atomic mass of uranium correct to 1 decimal place. Now, usually we say that write your answer to 3 significant figures. But because this question has specified what you need, you are going to just use that. Now, before we do that, what do we need? Every time you're trying to look at the mass number, you have to add the protons and the neutrons. But ignore the electrons, because electrons are really light. So in this case, we will create another column for the mass number, which we usually say A. Now, if you add 92 and 143, you get 235, which is the atomic mass of this isotope. And when you add 92 and 147, you get 239, which is the atomic mass for this isotope. Now, this is the mass, and you need to multiply with the relative abundance. And relative abundance is always given in percentage, just like over here. If it's not given in percentage, it's a ratio, or you can just divide them by the total of these. So 235 times 72, and the sum over here is 100, so I can just divide it by 100 if I want to, plus 239 times 28, because that's the relative abundance of this thing, and divide it all by the total, which is 100. Now if I do that, my answer comes out to be 236.12, and because the examiner asked me to write it to one decimal place, my final answer is 236.1. And there you go. Now why is this of 3 marks? Because 1 mark is for finding out the mass, 1 mark is for doing the right method, and 1 mark is for the correct answer. And there you go, we have gotten the marks. Next they're saying calcium is a metal and fluorine is a non-metal. Draw the atomic structure of an atom of calcium and a fluoride ion. Notice that this is a 2-mark question and there are 2 main requirements. You have to draw the atom of calcium, that's 1, and you have to draw a fluoride ion. So you have to draw both of them. This is not a question asking for calcium fluoride. You have to draw both of them separately. So let's start with calcium. Calcium has 20 protons, so we'll draw 20 electrons, and one idea here is that whenever you're drawing this, just for the sake of clarity, take the protons and write the configuration. So it's going to be 2 in the first one, 8 in the second one, 8 in the second one, and 2 in the last one. If you don't like that, another way to do that is that look in the periodic table. This is in the 4th period, which means you have 4 shells to fill. And it's in the second group, which means the last one has 2. So just fill the ones. They are full. So the first one is full at 2. Second one is full at 8. Third one is stable at 8. Although it's not full, but it is stable at 8. So there you go. That's the configuration. So just copy that one when you're drawing the atom. So first one, second one, third one, and fourth one. And first one has 2. You can use a cross or you can use a circle. Second one has 8. Third one has 8. Always put them in pairs. And fourth one has 2, and there you go. And now you have to draw the fluoride ion. Now fluoride ion is F minus, and that means that fluoride, which has 9 protons, and usually the AR is 19, but this has 9 protons with 1 extra electron. That means the total is 10 electrons. So the configuration again is 2, 8. So we'll put F here. Do not put the negative charge here. Draw the circles. Now try to use a different symbol. Instead of using crosses, I'm using circles here. So 2 in the first one and 8 in the second one. Now notice that this is an ion, which means you need to put square brackets with the charge here. So that's negative. So you've drawn both of them and you have fulfilled the requirements. Let's look at the next question. How does the atomic structure explain why calcium is a metal while fluorine is a non-metal? So it's really simple. Calcium, you can use the symbol Ca or you can use the full name. So calcium has 2 electrons in last shell or valence shell. And fluorine, do not say fluoride, fluorine has 7 electrons in last shell. And that's good enough. If you want to explain it any further, you can say that calcium has 2 electrons in last shell, which it's likely to lose, and fluorine has 7 electrons, which is likely to gain 1 to make it stable. Next question, why is fluorine in group 7? Again, because you don't need to copy the question. So because it has 7 valence electrons or 7 electrons in the last shell. In fact, you don't even need to write the because thing. You can just say it has 7 valence electrons or 7 electrons in the last shell. Whilst calcium in period 4, so what they're technically asking you is that what does the number of periods show? So you can say that it has 4 filled shells. Notice that it's important to write 4 filled shells, but you can also say 4 shells because in O levels that is acceptable. Define the term relative atomic mass. This is a technical definition, so it's important that you define it correctly. So we'll start by saying that it is mass of an atom, but again, this is relative atomic mass, so we'll say average mass of all isotopes. And again, to be better, you can say all natural isotopes, so naturally occurring isotopes of an atom. So that is 1 mark so far, compared with, obviously whenever you want to assign a number, you can compare it with a unit, And what is our unit in chemistry? It is 1/12 of carbon 12 atom. Now the interesting bit is that carbon 12 will have the mass of 12 and 1/12 of that is 1. So basically we're saying compared with 1 unit, and that is the carbon 12 unit. Next is saying deduce the electronic configuration of calcium ion. This word is important because we have been working with calcium atom, but now suddenly we have to work with calcium ion. So go back to the structure here and you can see that it has 2 valence electrons. This is 2882. So when it forms ion, it's going to lose these two and be left with just 288. So that is the calcium ion. If you want to write the symbol, it's going to be Ca with 2 plus, although that's not required at the moment. The ion is simply 288, and that's what you'll write. Next, explain in terms of subatomic particles why an atom of calcium is electrically neutral. Now this is a very important question because usually students will simply say that it is electrically neutral because it has same number of protons and electrons, or it has the same number of positive or negative charge. But what's important is that you have to refer to calcium because that's the question about. And secondly, you have to explain in terms of subatomic particles. Not just that, you have to also relate it to electrically neutral, electrical charge somehow. So here's how I would take it. So I'll start by saying that protons are positive. So I'm trying to build a relation between subatomic particles and the electrical charge. So protons are positive and electrons are negative. So what I've done is that I have talked about subatomic particles and I have related them to the electrical charges, but still the neutral part is left. So we'll say that number or n number of protons and electrons is same in calcium atom. And there you go. We have connected it. So that's how we get 3 marks. 1 mark for saying protons are positively charged, electrons are negatively charged. That's basically a relation between subatomic particles and electrical charge. And then why is it neutral? Because the number of protons and electrons is same. They cancel each other out. It is equal. So many different ways of explaining the same thing, but all of them are correct if they convey the same ideas. And that's it. That's how they ask you to answer questions on atomic structure, and that's how you approach it. Good luck.